And mind it, when you are going to appear entrance exam, organic substances are covalent compound. So in that case, they exist in gaseous state, they liquid, and if they are solid, their melting point is not that high because they are covalent compounds, they are not ionic compounds. So they are not that high melting point compounds. Yeah, even if some of the melting point is high, so even if the melting point is high and at that temperature, if you melt it, it decomposes. So now question is that how to purify them. See, purification of solids can be done by the process of crystallization. So in this process, what happens? The impurities goes into solution and the organic substances, pure organic substance comes out from the solution in the form of crystals. So one has to be little experienced that once you start working in the laboratory, automatically you will get experience. That is, we are trying to make a saturated solution of a compound in which it is not that highly soluble. And from there, if you concentrate the solution, means if you reduce the volume by heating it, then in that case you leave it at room temperature undisturbed. You'll find nice crystals of the compounds are coming out. Now, if it is a mixture of two solid compounds, in that case you try to separate it by fractional crystallization. In fractional crystallization, you find that two substances having different melting points, they crystallize in batches. One which is less soluble, it will come out from the solution at the beginning. So you filter that and filtrate again, you concentrate. In that case, you'll find the second substance will crystallize. So that process is known as fractional crystallization. Now coming to the liquid, it is if the liquid is containing some impurity, in that case, the main liquid substances is being purified by the process of simple distillation. You distill it and the compound comes in pure form. But if it is a mixture of liquids, in that case, we go for fractional distillation. In fractional distillation, the liquid with less boiling point will distill first, followed by the higher boiling points. Okay, and it is not a simple distillation process. A fractional column is being attached with the distillation unit, and from there you find fraction after fraction will distill. I'm not going into detail. You can read. You can see the diagram in your book. So that way you can separate by fractional distillation. Fractional distillation you will find is, suppose if you make a trip to a petroleum refinery, you will find how beautifully they separate different types of forms of the hydrocarbons by long fractional column is there. If you happen to go towards Guwahati, in Guwahati, Narangi or Nunmati, you will find this petroleum complex is there, and you will find a very long tower is there. This is nothing but the fractional column. So by this process, they separate different fractions of the hydrocarbons and they sell it under different names. Some is being sold in the name of petrol, some is sold in the name of kerosene or aviation fuel. Then from there you get the mixture of hydrocarbons, which is called naphtha. Then after that you get mobile. Sorry, after that you get diesel. Then you get mobile and so many things. Okay. The gases are being separated by the process of diffusion. It is anyway not being included in your book. And this is being governed by a very famous rule, which this rule I have discussed in the very first chapter, some basic concepts. Okay, it's called Graham's law of diffusion. But all in this in this process of separation, some form of impurity may remain there. So the best way to separate this mixture is a process called chromatography. Okay, chromatography. In the chromatography process, you can purify the compound. You can separate the mixtures very efficiently, no matter how many components are there. All of them you can separate. So this is something about the purification of organic compounds. Now today, which we are going to discuss is analysis of organic compounds. What is the meaning of qualitative? Qualitative is just the information. Suppose someone asks you, please go and check the crowd. Or see, anyone has come. So you went there and you have come back. So you'll tell, no, people are there. Then if someone asks you that male and female, both audiences are there, but yes, they are there. But if someone asks you, did you count how many male and how many female are there? Then this is not qualitative. That will be quantitative. Okay. So we are going for qualitative analysis of organic compounds. Now, we know in organic compounds are the compounds of carbon. So if you want to detect carbon in organic compound, so obviously it will be a foolishness, because it's a compound of carbon only. But still, if someone argues with you, then how do you know it contains carbon? Okay, do you have any experimental proof? Then you cannot answer, because you did not do any experimental analysis of this one. Okay, you have not done any test presence of carbon. So we write now here 1 detection of carbon and oxygen, both are done together. Detection of carbon and oxygen. What do? We burn the compound. Compound is burned. Sorry, I made a mistake. Only carbon. Oxygen cannot be. Oxygen we will find in some other way. So if I burn organic compound, what I will get? Say it is CXHY. I have burned with oxygen. So I will not write anything like N. What it will give us? It will give us, say it is 2Y. So it will give us X number of carbon dioxide and Y number of water molecules. Okay? You write here heat. Or you can say burn. Okay. So I have to, if I can detect carbon dioxide, then there is a proof that a compound contains carbon. So what I will do now? I'll pass this gas. These are all gas. Because I'm burning. So mixture of the gas is passed through lime water. Do you have any idea what is lime water? Hello? Huh? Lime water is not the vegetable lime or fruit. It is calcium hydroxide aqueous solution. Which turns it milky. Means what? White precipitate. Let's see what happens. Yes, aqua water solution. When you pass carbon dioxide through this, it will form this is solid. This turns it white. So this is a proof that carbon dioxide is a proof that gas contains carbon dioxide. When it proves, that is, we know this carbon dioxide has come from the organic compound. That is, we can say indirectly organic compound contains carbon. Okay. Now, without burning, also you can do it. Instead of burning, what you can do? Organic compound is heated with copper oxide. Okay? Copper oxide oxidates the organic compound to give you carbon dioxide and copper. So same carbon dioxide, when you pass it through lime water, you will get here. Okay? So this also will be white. If I have to tell done, then today I will not teach further. Now, detection of nitrogen, sulfur, halogens like chlorine, bromine, or iodine is done by Lessines test. Okay. Now what is Lessines test? First you have to prepare Lessines filtrate. Lessines test is done from Lessines filtrate. Okay. It is prepared by the heating organic compounds containing nitrogen, sulfur, halogen, or iodine. Along with metallic sodium at high temperature in an ignition tube. See, ignition tube, I can show you. The size is hardly this much. This much. It is a glass tube. Okay? I can show you. This is the size of ignition tube. Exactly the size. But it's thinner than this. It is made of glass tube. So there only we put the metallic sodium. So this is the hole. Hole is there. This is the hole. Here I will put organic compound and the metallic sodium here. And if the compound is liquid, so what I will do? Because if I heat it, liquid will evaporate. So I will take liquid and to that I will put little bit of sodium carbonate. Make it as a paste and we'll put the paste inside. And we'll put sodium metal and we heat it, still it is red hot. In case of liquid sample, a paste of it with sodium carbonate is used. The ignition tube is heated till it is red hot, and then it is plunged in distilled water. Okay, how much you're supposed to take? 10 ml, not more. Moment you put it in hot water, it breaks. The glass pieces are crushed and boiled for some time. And filtered. The filtrate should be colorless and is known as Lessines filtered. It takes only 10 minutes time. Okay, and further for heating 10 minutes.
Done, sir.
Okay. Do this heating, we ignite it. What happens? In the process of heating, for how much? Red hot. the organic compound decomposes to respective elements and combine with sodium metal to form corresponding inorganic soluble inorganic compounds. Okay. Alright, what are the things formed? Suppose the compound contains nitrogen. So we'll write now here. What will happen now? Sodium will be there, carbon will come from organic compound, nitrogen will come from organic compound. It will form sodium cyanide. B for sulfur. Sodium sulfide. Suppose compound contains for nitrogen and sulfur, both of them are present. So what is going to happen? In that case, it will be sodium, carbon, sulfur, nitrogen. It will give you sodium. Yes, sodium. So it will give you thiocyanate. D for halogen. Say it is X. What is this X? Cl, Br, or I. So it will be NaX. We will get now here NaX. Okay. What is X? If it is chlorine, it will be sodium chloride. If it is bromine, sodium bromide. And if it is iodine, it will be sodium iodide. So all of them are colorless. And mind it, sodium salt
all the sodium salts are soluble in water. Now the question is, why you have to do all this? See, you'll do in this thing in the laboratory. This time, because of this unusual situation, you have not done any practical. All the salts which are being given in class 2, they are water soluble. So from there you can test the different radicals present. But organic compounds are not soluble in water. This is the reason for which we have to break down the organic compound. Then we have to find out the different elements present. Okay. Now we'll go for test for nitrogen. So what we'll do? See. So what I'll do now? 1 ml of Lessines filtrate. Okay, I'll write it as a abbreviation is LF. Is taken in a test tube and is neutralized by dilute agent. Why to neutralize it? See now, what is the reason? You have taken sodium, compound contains carbon and nitrogen, so it has given you sodium cyanide. In practically, when you do it in the laboratory, the moment you plunge this hot test tube in water, you'll find immediately is going to catch fire. You know why? The reason is excess of sodium reacts with water to give you sodium hydroxide and hydrogen. So this is the one that you have to neutralize. So what we can say? Filtrate is alkali. This is the thing. So I have to neutralize it. I let nitric acid patch fatapat it will neutralize. Then to the solution. Freshly prepared. Ferrous sulfate solution is added, by which a dirty green appears. See now, what did I do? I've added ferrous sulfate solution. Now, ferrous sulfate solution will react with sodium hydroxide. This is colorless. Now, rest of the ferrous sulfate will react with sodium cyanide. This ferrous cyanide it gives you a complex. This is called sodium ferrocyanate. Okay, or also known as this is the IUPAC name. This is common name. One minute, so many things happen. After that, what we'll do? We'll add their dilute HCl. The solution is treated with dilute HCl. Treated with dilute HCl. Followed by the addition of neutral ferric chloride. A blue color solution. This blue color has a name. Prussian blue. I'll tell you what it is called Prussian blue. A blue color solution confirms the presence of nitrogen. See now what happens. Moment I add HCl there, the HCl reacts with dirty green precipitate. By that way, what happens? Solution become colorless. Moment I add HCl, solution become colorless. Okay. Now, after that, what is going to happen? See here, I have added ferric chloride. Okay. This solution is yellow. Okay. This is colorless. What it will give? It will give you Fe3, Fe4. No, sorry, sir. Look at this. This is blue. We call it. Okay, first I'll write the name of this one. This is called, common name is ferriferrocyanide. Common name. IUPAC name is iron 3. Hexacyanoferrate 2. This is known as Prussian blue. The color is called Prussian blue color. Now, why do you call it Prussian blue? See, before Second World War, there was a country in Europe known as Prussia. Okay, electron is got merged with Germany and Russia. So the army of this so-called country Prussia, they used to wear a uniform of the same color. Because of that, it is called Prussian blue. So much of equation that we have written, but the test of nitrogen takes hardly 5 minutes. We'll take the Lessons filtrate, to that we add dilute nitric acid. We'll shake it, and after that, to that we'll add ferrous sulfate solution. The ferrous sulfate solution, immediately you will find there is a green precipitate is there. So to that we'll add dilute HCl and we'll boil it for 1 or 2 minutes. Then we'll take it out, remove it from the burner, cool it, and to that we'll add ferric chloride, yellow ferric chloride solution. Shake it, you get a blue color. So it depends upon how much compound you have taken. If you have taken good amount of the compound, that will be blue, others will be pale blue in color. So that gives an information that compound has nitrogen. Now, test for sulfur. I don't know how much time I can spend with you. Hardly 27% is there in my mobile. Test for sulfur. Okay. Okay. Now I can do it in 2 ways. 1. The Lessons filtrate is neutralized by the addition of dilute to the solution. Sodium nitroprusside. Okay. So what is the formula? Na2 Fe CN5 NO. Okay. Now what is this name? Okay, name I'll add below. Sodium nitroprusside, okay, is added. The appearance of a purple color confirms the presence of sulfur. So let me write this equation. See, we know how, if the sulfur is there, what it is going to form? Na2S. This Na2S, when it reacts with sodium nitroprusside, So this is the purple color. We'll get this. Here we are going to dilute with acetic acid. Okay. To this lead acetate solution. What is lead acetate? Is added to obtain black precipitate of lead sulfate. See now, sodium sulfate I've already shown how it is formed. So when you add here acetic acid, it will give you now black precipitate.
Done, sir.
Okay. Now suppose if the compound contains both sulfur and nitrogen, If the compounds contain sulfur and nitrogen, then what is going to happen? See here. What it does, what it gives you? It gives you sodium thiazide. The presence of sulfur and nitrogen can be detected simultaneously by only one test, that is by addition of ferric chloride solution to the LF. A blood red solution confirms the presence of both sulfur and nitrogen. What happens now here? You will find here FeCl3 yellow, sodium thiocyanate, this is colorless. It gives you FeSCN3, the sodium chloride. Ferric thiocyanate, blood red color.
And sir,
Okay, now test for halogen. Remember, in organic compound, we detect elements, not the ions. Test for fluorine, bromine, or iron. The Resen's filtrate is neutralized by the addition of dilute HNO3 followed by addition of silver nitrate solution. Appearance of precipitate confirms the presence of halogen. Now we'll show you individually. So it is sodium, we know sodium plus X will give you NaX. X is chlorine, bromine, or iron. Now for chlorine, so I'll write now here NaCl gives you NaC. Okay. Now I will add here NaCl and silver. Like that. This is colorless. This is also colorless. So what we will get now here? AgCl, NaCl. This is curdy white precipitate. If I add here ammonia, white precipitate is soluble in ammonia. Why does it soluble? See here. AgCl, right here, S means solid. Ammonia. It will form Ag, NH3 to outside. Right. Soluble. Okay. 2. For bromine, see here. I'll write now here. Na plus Br gives you NaBr. NaBr plus silver nitrate. You get here AgBr plus Na. I've done a mistake. Huh? Sorry, dear. It's Na. Okay. This is dirty white precipitate. Insoluble in ammonia. Okay. Third, for iodine. So Na plus I gives you NaI. So NaI plus AgNO3. It will give you AgI plus NO3. This pale yellow precipitate, insoluble
in ammonia. Finish are being heated with boiled with concentrated nitric acid, and to that we add ammonium molybdate to get a canary yellow precipitate that you can see in your book. Okay, so now I'm going to close it because only 5% charge is there in my mobile. All right, and from next month I shall take 2 days in a week. Okay, I'll take 2 days in a week.